All right, hello everyone. This is the Ietf 125 meeting for the Quic working group. Can someone confirm that they can hear me in the room since both of our chairs are okay? Thank you. We're going to get started here. So, as usual, we'd like to remind everyone of the note well. This is the thing that everyone agrees to as for participating in the IETF. It's basically guidelines and rules for our conduct. If you have not reviewed it, even though you agreed to this as part of attending, please note it again. If you have any questions or concerns about the note well, you can reach out to the chairs or to the area directors. So much is the same for this meeting. The session's recorded. Make sure if you have not done so now, please use the on-site tool for those on-site. I'm not exactly sure actually what the people in the remote room do, but you know, use the tools. This will be how we do the queue, and so yeah, this is all pretty normal stuff. But please actually get it out now, so that we get the attendance recorded correctly. And this is the normal links for the things like the agenda, if you haven't seen those already. And after that, we'll start talking about the status of the various documents. Lucas, you want to do that?
Yeah, sure. I omitted the slide that we normally have about note-taking and looking for a volunteer. We're going to rely on the auto-transcriber here, but if anyone did want to jump into the hedge doc and just provide some manual notes, that would be appreciated too. Afterwards, Matt and I will scrub that and make sure the minutes are as we like them and presented and put in the various ways we do stuff, but we're not going to block on that for now. You'll see that this session today is a shorter one than we normally have. That's partly because we've cleared a lot of our work queue, and partly because Matt and I are remote and it's a terrible time zone for us. So instead of kind of giving more of the documents time slots, we just figured we'd give a quick, brief overview of some of the status, some of the documents that we have before passing over the agenda time to other things, which I'll come on to after these first few slides. So the kind of the sorry distraction. The first major thing to announce is the multipath document, or managing multiple paths, whatever we ended up calling it, is making progress. We went to the ISG ballot. That was like recently cleared of one of the discuss items. So big thank you to the authors and all of the reviewers to take us through that process. You recall last time we were going to submit it, so it feels like we've made very good progress there. We'll see how we move on with those things, but effectively that's done. Unless something comes back to the working group, we don't need to worry about it so much anymore. Hence why we've got more free agenda time for other things. If you recall from the last meeting, both ACT frequency and the reliable reset documents were in need of a shepherd's write-up. We've been a bit too busy to do those things. Unfortunately, those are on Matt and I to figure out. We're in a position now, though, where I think we're far more confident in what we put in that shepherd's write-up and to kick it on to the AD, especially in terms of reliable reset. For those who may be at the web transport session or weren't, there's been kind of more interop in the web transport land, who are our main driver for that extension. So we're a lot more confident that implementations are kind of at the point that they need to be. So I would expect by the time we meet in Vienna that we would have made more progress on those this time around. New to the working group is Qbucks. We had all of that discussion about rechartering and then an adoption call. So yeah, this is the new thing, and we've got a dedicated agenda time to discuss the open issues and proposals on that document that Kazuo will take us through. We have the extended key update. There's not really much to report here. My understanding is we're still waiting on progress for the kind of sibling document in the TLS land to make some more progress before the changes there are reflected back into the Quic document. Yaroslav told me that that the expectation is for the next meeting we'll have some like an updated spec and maybe agenda time needed for that. The Q-log, there's been a little change in the specs themselves. Authors have been busy. We're probably going to do something like we did last time, hold a virtual interim between now and Ietf 126 to burn through the remaining issues. But in terms of implementation, the Cloudflare Quiche Q-log library and the Quiche thing itself migrated to the latest schema. We landed that within the last week. I'm still under the understanding QViz will be updated soon. I don't know if Robin's on the call and wants to put anything in the chat for that, but that's my understanding. We have the receive timestamps, which we'll just cover in one slide. That was the update that the authors gave us, rather than have a dedicated agenda time, just to get come up and present one slide. And any other adopted documents we have that are not mentioned, there's not really any significant updates there. They're just same status quo as they were. Next slide, Matt. I don't have control. So yeah, this was the update from the timestamps authors for us. They published draft 02. What this does compared to earlier drafts is pick some temporary work in progress code points for the frame types. So actually implementers can go and interrupt now, which is good. There's an open issue in the security consideration section, which is important, but not necessarily critical for people to start doing work. And you'll see we've got Move Fast and Google Quiche planning to update their implementation. So the signal we've had is now is a great time to go implement and experiment. There's not been significant changes in the draft itself. So it's not like, oh, we want some reviews and feedback, but go and play and use that implementation experience to provide any feedback as usual on GitHub as issues, or just on the mailing list for discussion. Cool. Next slide, Matt. And then onto our agenda and agenda bashing, if there's any. We have just one working group item this time, QMux, 20 minutes there. And then kind of our as time permits bucket. There's a session or section, whatever you want to call it, on Mock2 over QMux. Anyone who was in the previous session at Mock would have seen Suhas present on this. We don't care about the media stuff in this working group session. The reason I wanted to kind of give a little bit of time on this quick working group agenda is because of the relationship with advertising application protocols over QMux. We'll probably get into that in the QMux session itself, but I think it'll help just to see an example of some of the challenges application protocol designers or developers are having here, and what we might be able to do to do them. Then we have a presentation about minimum RTT estimation. Sorry, that's duplicated. That's a typo from me. Sorry, 2 items for the same thing. That's not correct. Apologies. And application of explicit measurement technique for quick troubleshooting. Is there any agenda bashing that people would like to do? I see Kent in the queue.
Yep, this is Kent. If there's any time remaining at the end, I'd love to have a couple minutes to start a conversation about supporting call home over Quic.
I don't know what that is. We'll see how we do for balance of time, but I don't typically, given I don't know if anyone knows what this thing is. We wouldn't normally accept a last minute agenda request.
Start the conversation.
Okay, well, as a note to people, if you do want agenda time, we are always oversubscribed, so do put that into requests to the chairs ahead of the meeting. Anyhow, that's it from us, from the chairs. Let's hand it over to Kazuho to talk about QMux.
Go for it, Kazuho.
Right. So hi, everyone. This is Kazuho, and I'm going to talk about QMux. Next, please. Right. So finally, the draft has been adopted. And so let's close the issues. We have 13 open issues, and we have 6 pull requests. So let's look at them one by one. by first starting at the ones that we have the pull request. The first one is this 2-layer encoding. Next, please. So in the last IETF, Alessandro proposed using a different encoding, which is like this. Basically, Quic version 1 uses the packet boundary to determine the end of the stream frame and datagram frames that don't have the length field. But QMax 00, as currently it stands, uses a different approach, which is that if the length field is omitted, then the value being exchanged by the transport parameter is being used, with the default being 16 kilobytes. And that causes a slight divergence between how the frames are encoded and decoded. So the proposal was to have instead a record layer below the framing layer so that we can use it to identify the frame boundaries, much like we do in version 1, much like we do in Quic version 1. And that would make the frame encoding and decoding logic perfectly identical with what we have in version 1. Next, please. And then there was another question being raised, was like, I mean, it's not generally about standardization, but the question was like, what if we wanted to port QMax to WebSockets? And because WebSockets has the messaging layer, it's much easier to port QMax to WebSockets if the QMax has a notion of records, because then we could use, instead of the QMax records approach, the WebSocket messaging layer as a unit of sending the set of frames. So next, please. The proposal, the pull request here actually implements the 2-layer approach. Basically, we'd have something called QMax record that is a size prefixed field that contains one or more frames. And the benefit here is that, as said, the frame encoding decoding becomes identical to that of version 1, and it becomes easier to put QMax onto something that has a message-oriented streaming format. And the downside is that when you are setting large objects, like large frames such as 16 kilobytes, there's a slight increase in overhead, but it's only 2 bytes, so maybe we don't need to care. And so personally, I think this is a good compromise, but I'd like to hear what people think. Any comments?
I can hop over here. I have a question about how you plan to map this over a transport like WebSocket, which already has a framing layer. Are you saying that mapping would omit the QMux record? Is that what you're saying?
Right, just omit the size field because.
Yeah, sorry, the frames would be there, of course. Right. But you would, so this is somehow an optional layer that would be determined based on what your underlying transport is. You have to negotiate it.
I mean, in case of TLS or a TCP or whatever, the byte-oriented streams, we'd have to use this record format. And we would only specify this because that's what the charter says. But if somebody wants to port it to WebSocket, then they can just swap the recording layer to what WebSocket already provides.
I think I'm next. Yeah, for context, I filed this issue because I'm doing it over WebSocket, and the Quic stream frame, if you don't specify a length, it says it goes until the end of the frame, which I'd like to be the end of the WebSocket frame. But right now in QMux, it specifies it's based on the max frame size, which is like 16 kilobytes or something. So you can't use that. You can't use the WebSocket framing. So I think this is great. Basically, WebSockets, you could use its framing, and if there's no framing in the protocol, use a QMux record, like over TLS.
Hi. I don't entirely remember the discussion from last time, maybe due to the time here. But I think the compromise here is, rather than using like a full Quic packet header, then we use this QMux record instead. to sort of frame the actual quick frames, which I think is a good compromise. I don't think the overhead is really an issue, so I think this seems like a good solution.
Lucas, speaking as an individual here, yeah, but back when Alessandro proposed this, I didn't understand what he meant. So, but I'm going to ignore that. What I saw in this proposal makes more sense to me. It seems to make some of the handling around like the awkward text we had about, oh, if like it's all the same, but if the length field is omitted, it means a different thing here and all of that. I could see from an implementation perspective how this record thing makes things a bit easier. So I like the idea. There's a few other alternatives that kind of went through my head, but on the balance of what the overhead would be compared to what it enables and the trade-offs, I think this is probably the way to go.
Yaroslav, I am generally not a big fan of additional encapsulation layers, as they create bugs and issues and performance inefficiencies. I wonder if we could accomplish the same outcome by allowing a stream with endless streams, those that is streams that end and go until the end of underlying framing, and would allow that only when QMUX is sent over things such as WebSockets that are message oriented. Wouldn't we achieve the same outcome without introducing additional encapsulation on byte streams?
Right. So the primary target of running QMUX on top of is TLS, right? And TLS doesn't expose the boundary. It's not just because the TLS stacks are designed to not. Actually, the RFC itself says that it is totally up to the TLS stack to determine how they chunk the records. So we cannot rely on that property when we are using TLS. And I think that's the blocker we have.
Right. So for those transports that do not allow, do not expose size of the message, such as TCP or TLS, you always mandate size of stream or whatever. And then for things such as WebSockets that have message boundary, you allow endless stream or stream until the end of the message. Would that solve this?
Yes. I mean, so that's what this proposal says.
Okay.
Antonio, mostly as an individual. I think as a similar point as the one that was just actually discussed related to like TLS, we do not want to use TLS record boundaries to actually use as a delimiter in any way, especially because we don't actually want to like introduce extra TLS frames just because we actually want to like end a particular frame somewhere. Anyway, that's it.
So do we have some sort of consensus here, like emerging?
It sounds to me like there's kind of support for this proposal, at least compared to what we have already. So with the chair hat on, I would say let's try it. None of these decisions are ever final, but that yeah, let's look at taking this to the list maybe to confirm, but that we would land this, and all of the stuff we're going to talk about now would end up in a new draft revision and allow people to get some implementation experience. It's a bit hard right now, I think, talking in some of the abstract. Let's go and play and maybe come back, and we can always reevaluate some of these choices.
Makes perfect sense. Thank you. So next, please. So next is about the risks of deadlock due to flow control. Next, please. So Issue9 pointed out that we are using underlying transports like TCP, and they have their own flow control. So unless the QMUX stacks read what regardless of what the application says, there could be a deadlock. And for what was HTTP2 already had this problem and addressed this by saying that the stacks should never stop reading. So the idea would be to follow what HTTP2 says. Next, please. And the pull request actually does that. It just says that must continue reading from the underlying transport even when delivery of string data to the application is temporarily blocked. And that it must not couple reads from the underlying transport to application reads on any single quick stream. And that the Qmax stack may drop received datagrams when they cannot be promptly delivered to the application. And we also know that continuing to read does not imply unbounded buffering of stream data, as the amount of stream data that the peer can send is always limited by the quick flow control. So, I mean, this is kind of editorial in my opinion, but do people have any opinions? Thank you. So maybe we can just ask the mailing list and merge it. Next, please. TLS profile. Next, please. So there are actually two services being raised by issue 12, which when the first one is that even though the text already says what to do when zero RTT is being used, but it doesn't say how LPN should be used. And the second issue was that was the discussion about the TLS record boundary and if that can be leveraged when determining the quick frame boundary. Oh. And as we said, that's impossible due to RFC 8446. So next, please. And then there was the other question about how we would be using the Alpen. Like, for example, when we are doing the interrupts using a beta version of Qmax. And there were like two options, obviously, and the question was like, which one is better? So next, please. So for the Alpen side, we have a pull request, and it says that following what RFC 9001 of Quic version 1 said, we say that endpoints must use Alpen unless another mechanism is available. And that application protocols that use Qmax over TLS must designate their Alpen identifier and specify that they use Qmax. So Qmax is a dependency of the application, not being itself a Alpen or something, because Qmax is not an application protocol. It's merely a substrate of the application protocol. And we also had a note that when doing interrupt, maybe using something like mockd-14 and implying that it depends on the specific version of Qmax is just enough for interrupt, because specifying both the application protocol version in the draft and the Qmax version in the draft just makes the Alpen longer, and it's just a cost of finding the right matrix of the interrupt. So, any comments?
So Colin James, I mean, I don't have the knowledge of strong opinions on this, okay, but it seems that architecturally to me, if we think about there might be a YMUX at some point, and it might also sit on things that we often end up with these shim layers that are flexible with different ones and different things below them, different layers of them. And I like this sort of style of design we have with web transport, which each layer contains in it what the next layer is down versus trying to encode every single layer in the ALPN in one thing. So I think I would want to consider how this compared to a proposal where in the ALPN, you just said it was QMUX. And then in QMUX, there was a way to carry the next protocol that's layered on top of this is, Mach 14 or whatever it is, the application layer thing. So, I mean, do you have thoughts on those sort of two different designs?
Right. So one of the reasons we chose to use Alpen to express the application protocol rather than the substrate when we did Quic was that part of the reason is that RFC 7301 suggests that that's the approach. And the other practical reason is that when we have a load balancer in front, yeah, I mean, you have to look at the open to decide which backend the connection should be routed to. So it made sense to have the application protocol exposed in the handshake rather than doing the handshake, then determining where to forward the request. So that's I think.
Right. Oh, okay. So that makes sense. It depends whether you think your load balancer does the QMUX or not.
All right.
Yeah.
Hi. So I think the main issue with like just using the ALPN Mach T14 is we kind of have to specify which draft version of QMUX within Mach T14 is being used. Like it has to know that that is one of the layers that could be underneath. It also means we can't really ship Mach T unless QMUX also ships first as an RFC, because we'd just be pinned to whatever QMUX draft was latest when we rolled that ALPN. So I think it'd be nice if we just had some way of like some flexibility, like you can individually advertise like the application and the underlying QMUX compatibility layer.
Right. So I kind of think it depends on the goal. I mean, what you're trying to achieve, because I mean, if you are going to achieve interoperability between different stacks, you need to agree on the particular version of QMUX being used and the mock version being used. Unless you agree on both, you cannot have interop, right? So the question boils down to if you need two identifiers to specify one thing, one combination, or if you can just rely on a single version number to determine those two things. And I think it's ultimately up to the application protocol developers to decide which is better. But I mean, honestly, I don't know. And in terms of the QMUX spec, I think we have enough to say. And the added note is only about until it's being published. So in terms of specification, I don't care, is my honest answer.
Hi, Ben Schwartz. I looked at the PR. I think the PR is correct. I want to quibble with the slide only. The slide says Mach T-14. I think that needs to read Mach T-14 QMUX. We don't need to specify the QMUX version. That can be implicit for Mach T-14. But Mach T-14 is already the ALPN for Mach T-14 over Quic, and this is not that. We need them to be distinct for service B record processing rules, basically.
So someone mentioned WiMux or something like that as a potential thing that would be another layer. This is Cullen's sort of architectural question. I take the opposite view. These layers have leaky abstractions, and so you really do want the Mach T version that's specific to the QMUX being bound to this one, and that addresses. It also goes to Ben's point from just now. You need that in things like service B records to be able to say that. So I think this is the right design. It's not neatly layered in the way that we might like, but the identifier provides enough context for you to be able to make the right decision. I would probably spell it a little shorter than Mach T-14 QMUX or whatever, figure out a way to spell it so that it's succinct. But yeah, I think that's the only thing that you need to think about here.
Lucas, speaking as an individual, the PR does a really good job of making the requirements of ALPN clear. We can bike shed names and stuff. We don't have the time for that right now, but I think substantive change in this PR is the right direction and answers a lot of questions for people who've asked us similar things time and again since Kazuo and I came up with this years ago, and then had to explain it multiple times. So yeah, I think let's go ahead with that as an individual.
Thank you. So let's move on to the next one. Oh, we've done this. So next, please. Yes. Oh, that one before. Sorry. Yes, this one. So there was a request to put the transport parameters in the TLS handshake because doing so might speed up when we can start using the connection for exchanging data. And the counter argument that we had there was that it might be difficult in practice because some TLS stacks might not provide hooks to send and receive arbitrary TLS extensions. And the other argument was that the only case that gets blocked by not having the capability to send the transport parameters in the handshake is the server being blocked until the client sends the transport parameters when in one RTT mode, or when doing one RTT handshake. In all other cases, the endpoints can send the data as soon as the handshake concludes, regardless of the transport parameters being sent in the handshake, because both endpoints can send the last message that concludes the handshake and then immediately followed by the transport parameters on the value. So going to the next slide, please. The proposal is to just point that out. So we continue to state that endpoints must not send frames whose use depends on transport parameters until the PS transport parameters frame arrive. And this includes the use of stream frames. And then we point out that when 0 RTT is not used, the server sends this transport parameter in 0.5 RTT and the client receives them immediately after it obtains the traffic secrets. So there's no delay. And then that when 0 RTT is used, remember TPs are used, so there's no delay. So are there any ideas? Are there any comments regarding this approach? Does it sound fine enough?
David Skenazy. So maybe I'm missing something, but what's the motivation for not just reusing the TLS extension for transport parameters and doing the exact same thing that Quic does here?
Right. So when we developed Quic, the problem was that people had to struggle how to extend the TLS stack because they didn't expose the API for exchanging arbitrary extensions. And when Qmax is considered as a fallback, we need to support even more TLS stacks. So maybe the substrate might not be TLS at all. Then that means that we have all the complexities again, and probably it becomes harder to fix.
Thanks. That makes sense to me.
All right, so let's go next.
Just to try and interrupt here. We're technically at time, but we've only got a couple more issues with open PRs, and I think it'd be valuable to go through those quickly just to see if there's any commentary in the room. And then we'll move on to the next agenda slide. So if you could be quick, Kazuho, that'd be great. And if anyone has comments and is willing to maybe just stick them in the chat, I think that would be a good use of our time here.
Thank you. So this issue is about how omission of acts impact the quick state machinery and specifically the stream state machinery. So next, please. So the pull request merely clarifies that having no access is fine because, and the stacks can simply assume that the moment they write the frames to TLS or TCP or whatever the underlying substrate is, then they can assume in terms of the state machinery that they have been acknowledged. And behaving as such doesn't break the assumptions that Quic already provides. Any comments?
Yeah, I mean, I have been thinking about that quite a bit. I mean, I discussed that on the PR on your issue. I have a problem there with equivalence between the upper API of Quic and the upper API of QMux. In the case of MOQ, when we run Quic over MOQ over Quic, one of the things we have is that we get on the API, we pass information that is obtained from the congestion controller. as in you can probably send at 2 megabits. And in order to do that with TCP, it gets complicated. I mean, you have to do a whole new thing, and not having some kind of end-to-end say what is your RTT, what is your this, what is your that, does not help.
Thank you. I think that's a. I agree with the problem statement, though. I think it's kind of also now to having implicit acts, or I mean, how the acts drive the stream state machinery.
That is correct. It is not about, I'm sure that the user has received stream number 5.
Yeah, right.
But
So,
but it's about monitoring how the connection is progressing. Maybe we'll discuss that later.
Yep. Let's. Next, please. So this is a simple one. Next, please. So basically, the question raised was that maybe we should refer to multipath Quic as well. Sorry, multipath TCP as well. And the pull request is next, please. Basically, we say that in addition to TCP, multipath TCP is a viable underlying substrate, and that's it. Anybody have any opinions? Please.
I think this can be generalized. I mean, do we really care if it's TCP or some other transport that is doing multipath, as long as it provides us properties that we desire in terms of reliable and ordered delivery? Then multipath is, I don't think we need any text specific to multipath TCP. It can be any kind of multipath.
Yeah, I mean, we can just drop TCP as well if we base our argument on that rationale, but I think it just makes sense to just name a few reasonable choices.
We're at time, so please keep comments very brief, please.
I don't think this is true anymore. We just said that we actually also want to run over WebSocket, which is not a byte-oriented stream. So,
right.
so I think maybe we just want to rephrase this whole thing.
Oh, well, so to be clear, the WebSocket one is not something that the working group is going to specify at this moment. I mean, the task of QMAX is to specify how the compatibility layer should be run on byte streams. The WebSocket one is just an imaginary idea of how one might do it in the future.
So I think it's fine to mention MPTCP as an example, but given sort of limited deployment and unclear future, like I wouldn't do anything more than that, and I would also be fine with not mentioning it.
I would rather that we do not mention that at all. Because, I mean, the migration problem, the first migration problem I see is, suppose a mobile user that is having a quick connection and is moving inside an enterprise network that doesn't support UDP. So you're going to want to somehow migrate your quick connection to a QMAX connection somehow. That is the real migration problem. That's probably the most important migration problem. And so it's definitely not a multipath TCP scenario. So we have agreed at the beginning to not make things complicated, to leave those migration scenarios for later. And let's keep to that. Leave that for later. Don't mention it now.
Thank you. I think that's a logical argument. So maybe you can continue the discussion offline or the mailing list. Thank you.
Okay, cool. So we are at time. There are more open issues. Thank you very much, Kazuho. One of the things we considered, speaking as chair now, is running a virtual interim dedicated to QMUX to give us enough time and breathing space to talk about some of these issues. We'll probably poll a list and see if there's interest. I will note that previous interims were very unfriendly to Europe time. and again this one. So if we're going to do that, it's probably going to be something EU friendly. But stay tuned on the list for that topic. And meanwhile, please do implement and play. We have an open issue about code points for QMUX as well that I'd like to get us resolved for the next draft. Anyway, next up we have Suhas.
Hi. Okay, you're trying to load the deck.
While we're loading, Suhas, I know you talked at the mock session and we're a bit short on time. I don't know if there's much more you can add to the discussion we've had on LPNs and stuff, but
right. I'll just try to keep it really brief. So the idea here is that we wanted to kind of send mock or QMUX. The challenge here is that both the transport can evolve independently. And we had three possible options. One is that you do just mock and through QMUX set of parameters, you understand what the QMUX version is. That this has a benefit that, no matter what mock version is, that QMUX can change. And if both client and server support, you can get it happen. Or the other option is that, like what Kazo was kind of presenting, which is we have a combination, ALPN that's a combination of QMUX and some combination of the mock version. To Luke's point, is it does have the permutations kind of explosion where until both the drafts settle down, you will have to specify each version of both. And the third version was what Cullen was talking about, which is more, kind of slightly more work, but it's more, at least my personal feeling is that more cleaner, where the QMUX will be like how H3 in web transport, H3 is the ALPN that's just put not the mock, but that's the H3. In the same way for QMUX applications, the TLS ALPN will put in QMUX version, and then the next available protocols will say either H3 or it will say the mock version if you're using native Quic. If you're using the web transport, mock or web transport, the next available protocols in the QMUX parameters would say it's a H3, and H3 will get upgraded to what we call as the mock. I do think there are, each of these concepts have options have pros and cons, and whatever recommendation the Quic working group would help in QMUX, which will be helpful for the mock working group as well.
Yeah, when kind of suggested you come and talk, Suhas, I think we made significant progress this week on kind of unpicking the different overlapping issues. And I see Cullen in the chat suggesting that you and he can go off and come up with something and go back to the mock working group. So I think this is a good outcome, even though we only showed your introduction slide.
That's totally fine. I think important thing is that we're discussing this, so it's good. Thanks for inviting me.
No, good. And thanks for giving some time back on the agenda. It's much appreciated. Okay, next up we have Tong Lee. Are you in the room? Are you remote? In the room. Yes.
Hello. Yeah. Hi, Lucas. Okay. Hi, everyone. My name is Tong Lee. Actually, this draft has been discussed in the email list, and also Christine suggests me to go to the IRTF. But we don't have a session this time in Shenzhen, so I'm really appreciate for Lucas to give me the chance to share my idea on the calibrating minimal RDT and low ACK frequency. Yeah. So reducing ACK frequency is standardizing in Quic work group. So I don't have the control, right? So next slide. Can you help me to change to, yeah. So however, we find some issues and low ACK frequency. Usually when we send an ACK for every packet, then the sender can get the accurate minimal RTT estimation by tracking the per packet RTT samples. However, when we send fewer ACKs, we can only get one RTT sample for many packets. For example, if we send an ACK for every 4 packets, and packet 2 obtain the minimal RTT sample, but no ACK is sent for this packet. We only send a packet for the after the packet 4. So we might get a larger RTT sample. In this case, the minimal RTT estimation might be biased. Our experiments in Wi-Fi links report 8% to 18% larger minimal RTT estimation. This might be even worse in the satellite links. So next slide. So how to calibrate minimal RTT estimation? So it is recommended to use the one-way delay to by sending packets with the timestamps. Next slide. Thank you. First, we can calculate the per packet one-way delay at the receiver, and then we can recognize the packet who achieves the minimal one-way delay. In this example, the packet 2 achieved the minimal one-way delay. Next slide. Thank you. And also in this example, packet 5 is the latest packet. So when we need to send an ACK, the ACK delay and the departure timestamp of the packet 2, other than the packet 5, should be reported. So at the sender, then we can calculate the minimal RTT sample by using the T2, T1, T3, and the T4. T3 and T4 is the ACK delay. Next slide. So what's new for the Quic protocol? I think we have to add some add a new transport parameter called timestamp support. This is a new field a new field named timestamp support should be added to for negotiation between both parties. And also a timestamp frame. This can be reused according to the existing Quic draft from Cresting Hutima. And also it is recommended to use the main OWD ACK frame, a new frame to report the ACK delay and the departure timestamp of the packet who achieves the minimal one-way delay. Next slide. So in conclusion, a low ACK frequency biases the main RTT estimation, and also it is recommended a new method to calibrate the main RTT estimation. The receiver can calculate the per packet one-way delay and reports the timestamp selectively, and the sender then calculates the RTT samples according to the timestamps. We also need some modification to the Quic. One is the transport parameter. The second is to recall the draft from Hutima and introduce the timestamp frame. And also, it is recommended to add a new main one-way delay ACK frame to report the ACK delay and the time and the departure timestamps of the packet who achieves the minimal one-way delay. That's all for my report. Thank you very much. Any comments? Welcome. Yeah, I think that's all for my report. Lucas.
I was just going to say, please get in the queue, come and talk. I'm going to lock the queue soon just so we have enough time for the final agenda item. Yoshifumi, are you here?
Can I speak?
Yep, go for it.
Okay. My name is Yoshi from Apple. So thanks for interesting presentation. I just wondering, this is still useful with normal Quic. Let's say we Quic implementation send ACK every 2 data segment and use BBR as a congestion control. Is it still useful? You see some performance gain?
Sorry, what is your question about?
Oh, sorry. this I was wondering, this method is still useful with normal Quic.
Actually, for normal Quic, if we just send one ACK for every 2 packets, actually the minimal RTT estimation is not so biased. So I think we don't need this this patch or this modification. But if you have this modification, it still work. Yeah, the answer is still work.
Yeah, I just wondering if you have some data points.
Yeah.
But it's okay.
Okay, thank you.
Cool. Christian?
Christian Uitema, first, thank you for mentioning my draft. I'll be very happy to work with you to publish a version 09 of that draft and incorporate your ideas and do that. So just send me an email and I will give you, all the way to do that, invite you in the depot and all that. The one remark on the scope, the place in which I've seen that thing as most needed is with multipass, because with multipass we have lots of ambiguity on how to compute the delays of the different paths in a multipass session. So if I was to redo a new version of the timestamp draft, I would make sure that it can encompass the support for multipass. But as I said, I'm perfectly happy to work with you and update that draft.
Yeah, thank
David?
you. Yeah.
Yes. Hey, David Skenazy. Clarifying question. I think I might just be confused. We have a draft adopted in the working group called Quick Receive Timestamps. Why doesn't that one work for you?
Yeah, this is a very good question. Actually, this is also a very good way to calibrate the minimal RTT estimation, because we report more timestamps in the best effort manner, is it? So, but I think in some scenarios, for example, when the throughput is very high, then we have to drop some timestamps for one ACK because the packet size limitation. So we might report less RTT sample, timestamp samples as we need. So the sender still might miss the minimal RTT samples. This is one maybe a corner case. And also, I think report as many timestamps as possible might be, it is a common idea, and also it's useful in many cases. But in the mean RTT estimation, it seems it's more, it's costly. Thank you.
I see. Thanks for explaining. My suggestion would probably be to merge these two efforts because the use cases feel quite similar instead of having two separate exceptions.
Yes. Yes.
Cool. Thanks. And Kazuo?
Thank you for presenting this. And I have a question, and that is like, have you measured changes to PDO threshold or like time-based loss threshold? Because even though mean RTT might increase and SRTT might also, RTT value decreasing in that case, and then the loss recovery might become aggressive. So I was just wondering if you have measured those and the actual impacts on the loss recovery side rather than just talking about mean RTT.
I'm
Sorry,
going to
I
jump
didn't
in
get
there.
your
Sorry, Tongli.
question.
Just for time, we're quite short. So it's a
Yeah.
good question. I'd encourage you to take it to the list or follow up. There seems to be quite a lot of interest in this, especially in relation to the received timestamp. There's a lot of stuff in the chat as well that I'd encourage you to catch up on. And yeah, I think we'll need to close it there just so we've got some time for the final item.
Okay.
Okay, but thank you very much for your presenting here.
Thank you.
And Marcus, yes, in the room as well.
Do we have clicker support, or do you drive the slides? Or... Okay.
Ask Matt.
Yeah, okay. Hi, I'm Marcus. I'll be talking about bits again. Okay, so there's a lot of authors on this draft. The presentation is made by me and Giuseppe. Next slide, please. So a little bit of background. We defined the spin bit for RFC 9000. It can be used to measure round trip delays, but there's also desires to measure other things like packet loss. And there's also so that the spin bit has some measurement accuracy problems. It degrades with network impairments. And as most of you recall, there has been a lot of work going on here, a lot of discussions on how to enable different kinds of bits for different kinds of measurements and so on. That was handed over to IPPM working group, which produced a kind of protocol agnostic way to a protocol agnostic definition of measurement techniques using explicit bits in packet headers, and that resulted in RFC 9506. Since this one was published, there has been an attempt to kind of map some of these bits back onto Quic, and that is this draft, Quic explicit measurements. Some of the motivation for doing this is that there is a need, especially from operators, to be able to do things like diagnostic measurements. There are a lot of work going on now in the IPPM working group and other places on defining protocols and tools and frameworks for benchmarking. And usually they are driven by endpoints, but there's oftentimes a desire to be able to have measurements done at several vantage points along a network path, so you can kind of compose your benchmarking or diagnostic measurements over various segments of your network. Also, we believe that this work kind of complements a lot of lower layer telemetry work by basically tying measurements to application sessions. So in IPPM, we have defined a number of protocols that allow you to do measurements of very specific domains, like in using IPv6, MPLS, etc., to measure certain segments of your networks. But being able to actually tie measurements to specific application sessions is also very useful. Next slide, please. We'll skip this one. This RFC 9506 is presenting a bunch of bits that allows you to measure packet loss, delay, etc. We can go through this in more detail. We will be presenting this with a little bit more time tomorrow at Scone session as well. But some of the issues here. So we have defined a number of bits in this draft or in this RFC that allows you to measure loss, packet loss, packet delay, etc., etc. And there have been attempts on mapping this onto Quic, but the problem is really that, how do we fit this in? The spin bit was made a part of the short header of Quic 1RTT packets, but if we want to like have more bits going in there, we would essentially use up all available spare bits in the packet header, and we might not even have enough for the measurements we want to enable. So that's one of the problems with this. Next one, next slide, please. Another problem is that these bits in the Quic short header, they are greased, so they look very random at most points. There's also a possibility that these bits might get used for other purposes in various ways with different kinds of extensions. So kind of detecting when a session is a measurement session, or like when these bits are used for measurements is possible potentially, but it's not really straightforward. So yeah, these are some of the issues, and this is feedback that this proposal has gotten from Quic working group in various sessions. So what should we do? Next slide. Yeah, more AI slop. Next slide. Yeah, so the idea is to do something modeled on the kind of communication model that we have in Scone. So we want to make measurement sessions very explicit. So the idea is that we define a new packet type with a new Quic version, like we do with Scone, and these packets can then be prepended to regular Quic packets in the same UDP datagram as those payload packets. This would allow us to use 6 bits of payload in the first octet of that packet. And the Quic endpoints would announce support for this with transport parameters. And yeah, like I said, they would be inserted in front of regular packets in the same UDP datagram. Of course, these packets would, just like in the case of SCOAN, they would need to have the same connection IDs as the connection IDs in the packets that follow, because then you can ensure correct routing of these packets. So why would we want to do it in this way? Well, we now get an explicit measurement layer that removes the need of reserving space in Quic short headers, so you can use them for those bits for other things. It also makes it very easy to identify measurement sessions from the measurement nodes on path, because now we have a very explicit way of detecting that. And we also think that this is pretty much aligned with the lower layer mechanisms that we have defined for measurements. So we have this work called IOAM, which is basically doing encapsulations in various layers where we introduce various options for telemetry. So there are IPv6 options, MPLS, and so on. So this, in some sense, fits that spirit of doing things. Next slide, please. Yeah, that's how a packet could look. Next slide, please. There are, of course, a number of trade-offs and issues with doing it this way. So we're kind of doing this presentation as a heads up. We will also have more time to discuss it in SCOAN session tomorrow. But one significant issue or trade-off with this is that at least some of these bits require that you send this with every packet. But doing it in this way, you bloat the packet size a little bit, or the UDP datagram size. You would have you will require at least 8 octets of additional payload in order to make this work, probably more, depending on the connection ID lengths used in the end-to-end. Another interesting issue that we need to discuss is whether these things should be integrity protected or not. In SCOAN, we explicitly do not want these signals to be integrity protected because the network nodes are supposed to modify them. In this case, networks should not modify the bits, so we might want to protect them somehow. That would, of course, add a little bit of extra overhead and complexity, but that's something that could be done. Next slide. There are, of course, issues with faked or skewed measurements. This is an issue with the spin bit already, but endpoints may want to produce false measurements by setting bits that is not according to these algorithms that are described in RFC 9506. And of course, it's very important that networks observing these should not use these measurements to trigger like policy actions or so on. There are, of course, also a number of privacy and security issues that need to be discussed in this. For instance, the nice property from a measurement node perspective that you can very clearly identify and detect these sessions when you make them clearly identifiable like this, of course, also makes it easy to track that a certain flow is doing measurements, and this is something we need to consider. So, for instance, on-path adversaries might use this to track user behavior. On-path adversaries might also want to specifically target measurement traffic to disrupt operators by, messing with that traffic and so on. Next slide. There are more open issues as well. For instance, if we do this, we might be able to not need to have a spin bit in the short header. Of course, that would be a trade-off for, like, if you only care about the spin bit, this would add unnecessary overhead potentially and so on, but it could free up some space in the short header. Also, if we look at the methods described in RFC 9506, some of these methods require you to send the packet, to send the bits in every packet, whereas some methods require less frequent marking. So there could be an opportunity here to maybe negotiate specific methods depending on your need, and that might reduce the overall overhead. And I see a few people in the queue, and if we run out of time, we can discuss this tomorrow as well. So
we did already run out of time. We are over.
Okay.
I think there's, based on some of the comments, I'd like people to make their statements clearly. Yeah. And note that there is time on the agenda in SCOAN if you want to discuss this further. and there's mailing lists. So please go ahead, Ted, but please keep it as brief as possible to respect time.
Ted Hardy, because of the issues previously raised around plus SPUD and the spin bit, this needs a full BOF before it gets consideration for adoption anywhere.
Yeah, no, this is a heads up. So yeah, for sure. We're not asking for adoption at this point. Yeah.
Just maybe quicker. What Ted said, plus one.
Martin Duke, yes, BOF, but to the extent that you want endpoints to do this before we do this work, I think we need some confirmation that endpoint implementers are interested in doing this.
Yeah,
I'm a little skeptical, frankly. That said, like I hate to say this, but there's no reason an operator that's trying to do IOM type stuff can't just inject and remove these things at network ingress and egress, in which case a lot of those issues go away.
That's one way of doing it. It's a bit dangerous maybe, but yep.
Okay, I think we'll wrap it up there, Marcus. I know maybe you wanted a bit more time, but this is how the cookie crumbles.
That's excellent, thank you.
This going sometimes. For a brief wrap up, I don't think there's much to say. We have some clear emerging outcomes for the QMUX draft. I'll summarize that and send an email to the list, and then we'll look at getting the authors to merge some of those PRs and cut a new draft that can be an interop target, is what I believe. And yeah, for the other the documents or sessions that were presented, please keep that discussion going. Thank you very much, all, and I look forward to seeing you in the next meeting. Bye for now.